Okay, so we're gonna move on to this number 2 of topic 1. My little helpers are not here for this one, um, but we're gonna construct a histogram to analyze this data a little bit. So you're told in a survey, 26 voters were asked their age, so you know your sample size is 26. It's 26 numbers. Results are shown below. Construct a histogram to represent the data with 5 classes. So you're told how many classes to have. Beginning with a lower class limit of 19.5 and a class width of 10. So if we were to compare this with a frequency distribution table, just like the last one, the class limits would be from 19.5 to 29.5. And notice all our responses, none of them are half a year. The reason why you want to start at 19.5 is so that you are going to include all the possible values. In the other example, with nothing, there was no in between to fall on. In the histogram, it's a little different, and I'll explain that in a minute. So 19.5 to 29.5, and then between 29.5 to 39.5, and between 39.5 to 49.5, and then finally 49.5 to, no, not finally, 49.5 to 59.5, a little sloppy, 59.5 to 69.5. Now in here I didn't leave a gap at all for ages. What's the approximate age for the center, and does it appear to be normal? So we have to answer those questions after we construct the histogram. So what's the frequency? What's the frequency for each of these classes? So between 19.5 and 29.5, how many are there? Instead of rearranging all these in order, it's much easier to make a frequency distribution to get a count and then construct your histogram. So 19.5 to 29.5. So we're looking for the 20s, right? So there's 1, 2. I only see 2. All right, so I only see 2. We can just do that. 29.5. So the 30s. So we got 1, 2, 3, 4, 4. 40s, 1, 2, 3, 4, 5, 6. 50s, 1, 2, 3, 4, 5, 6. And then 60s. Let's see if we got everyone. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and looks like we got them all. So, what does a histogram look like here? So first of all, notice this little squiggly line right here. The whole point of doing that is to show that this scale, even though, ideally you start at 0, 0, 0 frequency and 0 age, there's a huge gap between 0 and the first value of essentially 19.5, right? So that's what that little squiggly line is, showing that there's a break. So what's the first data? So this is 19.5 to 29. 19.5 to 29.5. You can label these marks. And going up by tens. 9.5 and 59.5 and 69.5. So we can label our boundaries, our class boundaries, and then now we can label the frequency count. So down here would be age, and this would be frequency. label this age. And then how many times does this stuff show up? So the highest number I have to go to is 8. 1, 2, 3, 4, 5, 6, 7. There's only 7. There's only 7 notches, so I can't go by ones. I'd have to increase this line. I'm not going to mess with that, so I'll just go up by 2s. So this counts as 2, that counts as 4, that counts as 6, and that counts as 8. And then obviously that would be 10, but I don't need to go that high because I only have to go to 8 here. 8, 6, 6, 4, and 2. So now we construct our frequency. How many values between 19.5 and 29.5? So basically from 20 to 29. They fit inside here. So there's only 2. So we would draw a box up to 2. And then the same thing up to 4 here. Notice that these edges, the class boundaries, they connect. They're touching. Because technically there's no space between these boundaries. 39 to 49.5 is 6. Now the reason that we have the no gap between these boundaries, so 39, for example, 39.5 is the boundary, ends the boundary for the second class, and 39.5 begins the boundary for the third class. You don't want to. The histogram is always connected. It's always connected. This is 6 as well. So there's no gaps. So you want the data to fall somewhere, that data point. The next one is up to 8. I'm doing my best. Here, this is just and then make it prettier. You can fill it in if you so desire. You do not have to. To make it easier to read, you can always, though you don't have to, you can always put the number right up, the frequency count right above it. So there's no question on where it's actually lining up. Okay. So 39.5 to 39.5. So where would 39.5 fall? That would be the question. So technically, to be consistent, if you had a value that was on the edge right here, it would fall forward. So it would go into the next. It would go into the next count. But if you choose values for your classes that do not show up in your data, you will not have that problem. So notice that's why we started at 19.5, because there are no half values. So 20 will definitely fall in this class. If our number was 30, if you're 30 years old, where does 30 fall? 30 absolutely falls in this second class. That would change. That would be, well, slightly confusing if our class boundaries were 20 to 30 and then 30 to 40, something like that. Or 20 to 29 and then 29 to 20, 30, 30, 40. So where would 30 fall? It would be kind of confusing. So that's why we start at 19.5. Okay, so there's our data, our distribution. What is the approximate age of the center? So notice that this distribution, I'm going to answer the second question first. Does it appear to be normal? No. No, it is not normal, because normal distribution would start low, right? Go high, and then end low. There's my awesome normal curve, right? It would look like a hump. That's normal. Normal distribution. So it does not look like a normal distribution. No, because it doesn't start high. It doesn't start low, go high, and then end low. What's the approximate age of the center? So center could be the mean, right? Or median. Now, the best measure of center for a non-normal distribution would be the median, because it's resistant to outliers. It's resistant to those larger values. So if I'm answering this question, though technically you wouldn't be wrong if you said the mean, but I'm saying the best one would be the median. I would find the median number. So what's the median number here? Well, if I'm looking for the median, middle number, right? Middle number, there's 26 voters. So the middle number would be the average of the middle two, because it's 13 and 13 would be a half. So I need to find the 13th number and the 14th number, the response, the age, in order. So I'm going to start at the low end and say, okay, there's 2. 2 plus 4 is 6. 6 plus 6 is 12. So 12 of the votes are all right here, basically between 20 and 50, or 20 and 49 are 12 of the votes. So that means the 13th vote would fall somewhere in this class. The 13th vote and the 14th vote would fall somewhere in that class. So and then visually on the distribution table, it would be here. So the 13th and 14th vote are somewhere in this class between 49.5 and 59.5. I have no idea how old they are, though. Well, actually, I do. They're in these values right here. So I could do a quick approximation and say, well, the median is going to be the middle number of this, which is 55. Okay, that would be a good approximate age of the center, because I'm using the distribution to answer this question just in the middle of this 4th class. And I could say the average approximate age of the center is 55, because it's an approximate median. To find the exact median, I would have to organize all these numbers in numerical value, increasing value, and then find the middle number, which, okay, I know it's the 50s, so what I could do is I can just circle all the 50s here. There should be 6 of them. And then take the average of the middle two numbers here. So 51 is the lowest, 52 is the second lowest, 53, 53, 56, 59. So 59 and 56 are the two highest. So the middle two numbers of this middle group are 53 each. So that would be the actual median of this data is 53. Now, when you're asked approximate, what's the big difference between 53 and 55? When you're asked to be approximate, you're not going to be wrong when you give an answer, as long as you give reason for your answer. So I would have to give reason. The actual median of this data set is 53, so the approximate age of the center is 53. Or you can say, based on the distribution, the median falls in this 3rd class, and the average of that 3rd class is 55. Either one is correct, because you're asked for an approximate.